Hello, everyone. It's Assalamu alaikum. It's me, Akasha Amjad. I'm from Lahore, Pakistan. I study at Air University, Islamabad, Mechatronics Department. So I'm an undergraduate and I'm doing my bachelor's from there. So in my first semester, I studied a course named as Electric Circuit Analysis. So I just wanted to review that course. So in this video, we'll go through some of the basics of that course of electric circuit analysis. So what is electric circuit analysis? Basically, a course in which we go through some of the logics, phenomena, laws, and techniques to simplify a circuit or to learn some behaviors, some different behaviors of circuit and how to handle them, how to simplify them, how to solve the complex circuits into a simple one. So these are some of the basic circuit elements. There are five basic circuit elements: voltage source, current source, resistors, inductors, and capacitors. So basically, there are two types of circuits. One is the first order circuits, and second is the second order circuit. In first order circuit, a circuit having only one energy storing element, which is inductor or capacitor. And the second type is having two energy storing elements, which is having both inductors and capacitor in a single source. So what is voltage source? Voltage source is a source we give to a circuit that has two terminal circuits element. What does it mean? It means that it has two terminals having different potential. One is on higher potential, that is a positive one, and one is on lower potential. So the current flows from higher to the lower. The electrons basically flow from the higher to the lower, and that's how the current flows. Basically, current is the flow of electrons. So the value of the voltage is definitely the characteristic, defining characteristic of a voltage source. And a voltage source is always replaced by a jumper, which means if you want to simplify a circuit, you would replace a voltage source by a simple wire. So simple wire is known as jumper. So it's a simple wire. Current source. The current source is also a two-terminal circuit. It maintains the current through its terminals. It basically flows the current through the circuits, and the current's value is the main characteristic or feature of the current source. And if you want to simplify a circuit, and there you got a current source, you got a current source replaced by an open circuit. So in voltage source, we replace it by a jumper, simple wire, but in case of current source, we replace it by an open circuit. A resistor is a two-terminal circuit element that has a constant ratio of the voltage across its terminals to the current through its terminals, which means that the voltage at both ends of resistor is same, and the current just passes through it and it dissipates the current. So resistors basically resist the current, you can say. And the value of a resistor is the ratio of a voltage to a current, which means that if you divide a voltage by a current, you'll easily get the value of resistor. And we use an Ohm law here. We'll go study. We'll go through what Ohm's law is in this video. So, what is an inductor? An inductor is a coil of wire through which electrons move and energy is stored in the resulting magnetic field. It's like a spring. It's a coil of wire rounds. But what does a wire rounds about? It can be either in air. The wire wounds around in air. It can be a permeable material that concentrates magnetic fields, or it can be any circular form, and its unit is Henry. Basically, the inductor stores energy in form of a magnetic field, and capacitor stores energy in form of an electric field. So we have in capacitor we've got two conductive plates. Conductive plates means the plates which can conduct the electricity through it or the current through it. Two conductive plates separated by a non-conductive material. It can be material or either just an air, because air is also an insulator. Uh, so we can also think of a capacitor as a very small temporary storage battery. It stores the energy in form of electric field temporarily, and its unit is farad. Ohm's law is like very important law in electric circuit analysis. You basically use it almost in each and every technique and logic in circuit analysis. So you definitely use it most in electric circuit analysis course. or just to simplify a circuit. So it states that the current through a conductor between 2 points is directly proportional to the potential difference across the 2 points and inversely proportional to the resistance between them. The mathematical equation that describes this relationship is V is equal to IR. So it states that as we increases the current, voltage increases, or the other way around, if we increase the voltage difference, the potential difference among the two terminals of a voltage source, the current increases. But if you increases the resistance, the current decreases. That's how it works. Okay, there we go. So those were the circuit elements and the basic law. Now we gotta move to the some of the complex one, you can say. Kirchoff's current law or Kirchhoff's current law. So KCL is its short form. KCL states that the sum of the current entering a node will be equal to the sum of the current leaving a node. So what is a node? A node is a junction point where different circuit elements meet. So you can see that there are battery and resistor and resistor and resistors. All four of them joins at this wire, so it's a node. And same here, battery and these three resistors joins with this wire. Practically, if you'll join them, so you'll join them at the same place, so it's a node. So KCL states that the sum of the current entering a node, which means it's the sum of the current leaving from the battery and as it enters to different circuit elements, is equal to the sum of the current leaving from all the circuit elements from the same node. So as you can see here, the current leaving from the battery is 9. Or you can say the current in this node, in the first one node, this node is 9. But if you see here, the current 4 plus 3 plus 2 means the current leaving from all the circuit elements is 4 plus 3, 7 and 2, 9. It's equal to the current entering into this node. So that's what Kirchhoff's law, current law states. So here's a practical example. Here's a circuit in which we've got these two resistors in parallel. So there's current is 13.2. So in parallel, current is different and voltage across both of the resistors will be the same. So according to Kirchhoff's current law, the current entering into this node should be current equal to this leaving through this node. So here we have current 1.2 milliampere. Here we have current 12.0 milliampere, which equals to 13.20 milliampere, which proves us that the current entering through this node is equal to the current leaving through this node. Let's move on to the next one, Kirchhoff's current law, Kirchhoff's voltage law. So Kirchhoff's voltage law is the result of the electrostatic field being conservative. It states that the total voltage around a closed loop must be zero. It says that the sum of the voltages around a closed loop, it should be zero, which means if we sum up the voltages of different circuit elements, it should be equal to zero. Here we have an example. KVL states that the sum of the voltage drops around a closed pipe will be equal to the applied forces, or in other words, if it should be equal to zero. It balanced out. So if we sum all voltages across all the circuit elements, it should be equal to the total voltage of the battery. So here we have 3, 4 plus 5, which is 12, and we have got 12 on the battery. So it proves that Kirchhoff's voltage law. Now we go to Thevenin's theorem. Okay, so through the use of the Thevenin theorem, we have the ability to reduce a complex circuit down to a simple series circuit. Say, in Ohm's law, through Kirchhoff's law, through Kirchhoff's current and voltage, both of the laws, we were basically proving something. And then we have got the theorem in which we can simplify a circuit. So basically, 4 steps. I remove the load. So load is a circuit element, through or across which you want to find a current or voltage respectively. So first of all, we got to remove the load. So from the circuit, we remove the load. As you can see, we remove the load. Here is the load. We remove the load and then determine the voltage seen by the load, which means to determine the voltage here. Then we're going to replace the voltage source with the short. As I told you in a voltage source that we always whenever we simplify a circuit, we replace the voltage source with a wire, which we also call a jumper. So we replace this thing with a jumper. As you can see, this is a voltage source, and here we go with the jumper. Now we're gonna calculate all the resistance here, determine the resistance, which is, so you're gonna see basically whether it's in the series or the parallel, and the sum them up. So it flows, the 3K ohm flows, and this resistor also flows, and we just, and 3K and 4K and this resistors are in series, so we're just gonna sum them up. So there we go. We just sum them up, R1, R2, R5, and we apply here a formula. Since R3 and R4 are not connected on one end, they do not carry current. So basically the circuit is open here, so both of them, we're going to neglect them. They are going to float, and this is how we find. It's basically the circuit reduces from this to this. This is our load. This is our load. We're going to calculate all the resistances. We already have a voltage. We then we're going to replace that resistance, the sum of the resistance and the voltage in series, and attach the load with it. And we're just gonna know what we want to know, whether the resistance or the voltage about it, or sorry, the voltage or current, and we can also find the resistance about that load. That's how we simplify the circuit using Thevenin theorem. Let's move on to the Norton's one. In Norton, we reduce all the elements of a circuit to a single current source and a single source resistance which supply power to a load. A simple circuit can be created. We find a voltage and place it in series with with a total resistance, the summed up resistance and the load. But in Norton's, we place the current source and our Thevenin, you can also say our Norton in Norton's theorem force, and the load in parallel. As you can see here, first of all, we remove the load. We got to know here the current. Then we add a jumper wire on the voltage source. Then we summed up all the resistances, and then we place them in parallel. So that's it. That's all. I hope it went well, and I hope you got to understand what I wanted to say. So thank you.